and after that some reports were published by United States Geological Survey, and some of the countries, they have published some disciplines on this river health. Now what is this? This term, traditionally the term river health is dependent solely on the measurement of physical, chemical and biological characteristics of the river. We know that river is getting polluted. So these are the features which is related to this river health. It is usually applied to the assessment of river condition and often found as analogous to human health. Sets of ecosystem level indicators actually identify or how physical, chemical and biological characteristics may be integrated into, just I told few minutes back that if it is project based time frame this limited, then it is very difficult to take any type of necessary action for these dwellers in Chor Islands. But I was going to ask one point. In this part of this West Bengal or India, you can say, you have missed in your diagram that we are discussing is politicians, role of politicians, not the planners. If you see, and in many cases if you find that they are occupying this Chor Island and trying to do, and by this way the river health is getting deteriorated. Chor is itself a component of river health, I'll tell you. Afterwards will come. Now river health is exclusively a new branch both in geomorphology and hydrology as well as in environmental science. So here Norris and Thomas in 1999 they have published one paper, What is River Health? And since they were biologists, they tried to define the term from the biological point of view. But after that, they have tried to incorporate some of the hydrological parameters, but it was incomplete. Now, physical characteristics of the river include the fluvial geomorphology and surface hydrology of a river basin, which control the structure and dynamics of river channel. So, not only this hydrology, when it is changing, then geomorphology of the river basin is changed. So, they are this contemporary phenomena. So, that is why this dynamics and structure of a river channel is changed due to this hydrology and geomorphological changes. Changes in flow sediment regimes following catchment modification can markedly alter the physical nature of the channel. Moreover, the chemical indicators are also important because some of them they think that if the chemical components of the river water is deteriorated, the whole river health is deteriorated. So, by this way there were some individual publications, but not on river health in a cumulative term. Certainly, it is argued that if the riverside habitat is in poor condition, the health of the stream would be affected adversely. I was mentioning this one. In most of the river valleys along, if you go to along this Balasan, I will come up to this. On the case of Balasan, see how many thousands of people are dependent on the river sediment. When I started this work, many of you did not see the light of this of the sun over the Earth's surface in 1993. So I started this work and followed by Professor Ramakrishna Maiti also came to this part and we worked in the same area in Darjeeling, Himalaya. And since then, the river bed has gone down because of the extraction of sediments from the river bed. That time there was hardly any sediment along the river. But nowadays, if you go to this Balasan river, just from the bridge and go to the upstream and downstream side, hundreds of houses have been constructed. And they are directly or indirectly impacting the river. So, this was the Norris and Thomas. These indicators they have proposed. One is sediment sequence, soil and sediment erosion, then stream flow, stream channel morphology, stream sediment, surface water quality and floodplain and wetland structure and hydrology. See, in this part, mostly they have tried to concentrate this hydrology and geomorphological parameters along with this one point is surface water quality, but in components they did not or they could not do the divisions or subdivisions properly. So that is why afterwards in our book published in 2017, we have tried to classify these indicators in three categories. One is river hydrology, one is geomorphology, and then river water quality. And after that, other indicators, there were components, sediment, discharge, cross-section, form processes, hazards. See, in geomorphology, form and process are very important, which is the difficult task to do research work, especially in a country like India and developing countries where funding and instrumentation facility are very less. But it is not 100% right that we do not have merit. We have very high quality merit. And like Mehboob, many of the leading universities in the world are ruled by this Indian scientists also. Say, just a few minutes back, our registrar has said, our dean has said, that if you go and try to be like Mehboob to go abroad, it is right, of course. Sitting in your country, how can you contribute to your society? How can you rule the whole world? I did never think. So that's why, and like him, he is in UK, my opponent was UK. And after that, when I won the election, it's a difficult task to do work in India, but it is not impossible. Our teachers, they have shown, try to synthesize it. River health may be defined as the condition of the anatomy and physiology of any river. As I told earlier also, anatomy of any river mainly includes the physical condition of the river, including the changing hydrological behavior. But our anatomy and physiology is related to our health. So thus, river health is a subject which combines fluid. It is very difficult to free all the rivers from any type of human intervention, especially in the developed or third world countries. Now, as an example, I will come to this anatomical part. Although we did many works, if time, but since I told you it is highly dynamic in nature, this braiding. And why it is highly dynamic? Because of fluctuation of rainfall, because of fluctuation of sediment supply, fluctuation of discharge from during monsoon period. So fluctuating, and it is highly dynamic. And this there is hardly any model in the world till today to study this braiding. Sometimes it was believed that braiding can be formed in a downstream side of a river, but after that in many rivers in the world it is found that within the hillside areas braiding can also be formed. So now what is the relation with braiding? I will show the figures you can understand. So this is Balasan River Basin, and from Dudia, if you go up, from Dudia to till this confluence point of this river Balasan with this Mahananda, this part is highly dynamic, 35 degrees. In landslide science, if you take a bucket of sand, if you pour it on surface, it forms 34-degree angle. But all slopes in the world is not formed with only loose sand. So that is why in landslide slopes more than 40 degrees, it is called vulnerable slope if other factors remain constant. So in that case, Darjeeling Himalaya in many places more than 35 or 40 degrees. In many places, if you see 1817, where in Darjeeling Himalaya only 10 huts were there, and more than 80% was covered with forest. But nowadays, if you go to Darjeeling town, you will find around 10% forest cover. And as a whole, Darjeeling Himalaya is less than 34% forest cover. So now why the forest has gone, big gigantic buildings are coming up for tourism industry, then agriculture, tea cultivation, then different types of crop production. In many places, if you go to Mirik, if you see the left-hand side, in around 2000, this rural topography was deforested for tea plantation, but till today it is lying like this only. So these are the parameters which changing the whole land use, land cover of the whole district. Now these are the data sources. I am not going into the details. We have collected so many data from different sources, and this is the whole methodological framework of this study. This is basin hydrology, which is very important. Then we have utilized one model which is called soil and water analysis tool, which is called SWOT model, and after that channel braiding pattern and associated dynamics, which is directly related to the hydrology of the area. Now if you see, so we have collected 4 series of time data. 1960 part of stream is due to discharge and for 23 million. Now if we see this water budget of these sub-basins, we will find in different places we have shown the amount of rainfall, amount of discharge and amount of mean annual discharge and sediment load, which is coming down the river and depositing in the river bed. So in all cases, it is almost similar in nature. Where this, you see this pink line which is discharge, and after that this blue line which is sediment yield, it is why mean annual monsoon period, when huge amount of rainfall takes place, it brings down huge amount of surface water discharge as well as low discharge, and this brings down the rivers. And after Dudia, at the point of Dudia, this is called the debouching point of the river, where the river is meeting within the plain area, and after that this deposition starts. Now this is the annual database. You see, this is annual surface runoff. We have calculated lateral soil, groundwater, then deep water, deep aquifer recharge, all these things we have calculated. Ultimately total sediment loading, it is 570 tons per hectare per year. So 570 tons per hectare per year. After this monsoon period, this local contractors and the laborers there, they become very happy to collect these sediments from the river bed. So this is not this pseudoscience, this is purely science, I tell you. And these are the stretches. These are the stretches where this braiding has been formed in the downstream side from Dudia to this NJP. And I will show some of the footsteps of this one. These are the changes. This is 1960 to 1970, these were the condition. Just see in segment 2, we'll show in segment 2 the top side. This is segment 2. Yes, this is segment 2 in the top side, top right hand side. Just see and see the nature of changes. Just look towards this. Now it was multi-channel, a big, this bar shoal has been formed. This is called jaw. This left side, this is dotted. This black dotted line. So this is the bar has been formed. Now again, if we see, this is 2000 case, the same place. If you see in 2008, this multi-channel is gradually being vanished. It has come into 2 channels. And these jaws have been formed like a point bar. It has mixed with the, it is meted with the river bank. Now again, if we see, some of the inner line inlets channel are forming, and gradually it is, so from multi-channel to almost unit channel is formed. One bar was formed within the river valley, then it is met with the river bank, and gradually the river bank is extending. People becoming very happy, they will get a place to settle over there or to cultivate the land or to do any type of practice to collect sediments from this. Now we have drawn this cross section since Dudia to this NJP. This long time we stayed here and we have drawn these cross sections in many places, and we have found the nature of channel cross section change. If you see many places, in many places not all, if you see this section, see middle one, this section D, that highly variable river bed. Now river when deposits, they do not form this one. Now if we ask why this river bed is inundated like this, people intervention, human intervention, they are collecting sediments from that one. Similarly, this way, this in different places we have done, and different. Now we'll come to this bed profile of this river bed. You know, this is the real diagram. You know, many geographers, they do not believe there is a term which is called river sedimentation. Usually, when the river carries sediment, the big size boulders, they are deposited first, then middle size, then fine, medium size, then fine size. So after that, if If you see the reverse case, the fine sediments have gone down and big sediments have come up. Geologically, this is called reverse sedimentation. And this reverse sedimentation takes place when there is any hazardous event or extreme event. In many cases, we find this one, and this is an indicator in which years and in which time period this extreme event took place. And in braiding, we have taken this, we did not dig this one, we did not dig this hole. It was dug by these local people. They are collecting sediments from that one. And you see, this is the natural sedimentation, but in many places we have found reverse sedimentation. Now, if we see this valley morphology, you will find that this is a relation between section weight and distance. So section weight is highly variable. In some places it is choked, in some places it is widened. If you see the places where it is choked, you will find many settlements are there. If you go to this Balasan bridge, it is in two sides there is embankments, but in many places there is no embankment. So those areas have been widened. So anyway, channel weight, braiding weight, it is changing throughout this one. I am not going to this now. I will show this braiding dynamics in different places. Section 1, just I will show this section 1, although all sections are there, you see this one. Section 1, right side it is 2000, 2008, 2014. You see, firstly it was two sides channel, then it is multi-unit, multi-channel, it is called hydrological, it is called multi-channel, and in 2014 it is again been, most of the channels are again been made together and form this wide channel. Now in braiding, it is highly dynamic. Why it is so? If it is natural, there is no point. If it is unnatural, with nature, human intervention, if it takes place, then this middle part is forming these bars, and it will form shoal, and if it continues for a long time, it will form riverine island. If you go to Brahmaputra, you will find several riverine islands, like Majuli is a riverine island. So, by this way they form, but they are highly dynamic in nature. Because in both sides, in braiding, one point you should keep in mind, that in braiding the main channel changes every year. Main channel changes every year. If it is flowing through this right side in this year, next side it may be left side or maybe through middle side. So that is why it is called highly dynamic in nature. There is no uniform model to study this one. But here we can see the braiding is being changed. And why will reply this question afterwards. In different places, section 3, section 4 and similar. They see this in section 3 left side, the number of channels were less. But in 2014, in the same place, the number of channel divisions have been more. So that is why our point is to ask that why this channel, this is being modified from unit channel to multi-channel to unit channel. These are some of the footprints we have taken from different, especially from these three. So now I'll come to this braiding index of the Balasan River. We have calculated on the basis of this common formula PI. And here you see in different segments, this braiding index is differing very highly in different years. And in segment 3 in 2008, the PI has come down, but in 2000 it was very high. So from this footprint we have calculated this one, and it is very simple. Without going to field, it is difficult to measure this braiding index. Many of you, they depend on this RSGIS in the laboratory, but what is the reality in the field, you must verify in the field. Similarly, this platform index. So these are the platforms where the small points are highly braided, and big green ones, they are low braided. And in this 4 segments, see, you look towards this map and you will see the nature of changes. Just see the first one, the top one. It was highly braided, this moderately braided, after that it is highly braided. Then again it is moderately, in some places it is highly braided. And then this variation of platform index in the lower coast, and if we see the distance, it is about 40 kilometers. And within this, in different places, somewhere there is forest cover, somewhere there is this embankment. So that is why it is highly fluctuating in nature, naturally, moreover human intervention. So I'll go very fast, I have 5 minutes time. So in discussion we'll see this monthly discharge hydrograph. If we see during this July to September, in many cases in Darjeeling, my record says that most of the extreme event took place in the late monsoon period, either in the last week of September or first week of October. So if you have the data, you will find 1968, this was the most devastating year when flash flood took place, and within 4 days 900 millimeter rainfall took place, and it was during the first week of October. And after that again in several cases we can find this one. So during this period, this first week of October, peak discharge, peak sediment load in many cases we find, and if we see the mean depth, it is also similar with this one. And after that, this river course is also changed accordingly. Now we have identified some of the zones where these sand mining sites. Here you see, we have detected from the field, not from any secondary or this satellite data source. These are the fields where this marking, red markings are there. These are the sand mining pits. If you go to Balasan, thousands of people are dependent during non-monsoon period. Not monsoon period, they cannot collect anything. Now these are the sand mining pits we have detected. Now this is the real photograph of the Balasan. You see two channels, and at the downstream side, they are meeting together and they are forming unit channel. And these hundreds of trucks, they are collecting sediment. If you go to collect the data, you will be killed. So this is, they are collecting, we do not know from where they have got the permission. And that is why I have requested him to incorporate one point. And if you go to collect this data personally from the trucks, they will not give anything. So you will have to, it is an art of research. You will have to find the alternative means to collect this data. So here, two of the scholars, we got it from North Bengal University. They joined under me, and they have some friends from Budhia to this near this NJP. All these places they sat together and they were discounting how many trucks of sediments are being collected regularly. So by this way, this data may not be accurate, but it is almost similar to the accuracy, but it is not 100% accurate. So see, they are collecting sediments, they are breaking on this coarse grain, they are collecting fine grain. Sometimes it is washing away with the river, and we'll show more pictures. This has been, initially it was a multi-channel, now it has been unit channel. Next year if you go there, you may not find this unit channel also. And you've seen both sides. Now these are chores. This is chore is highly, you see the definition in any geography book. Chore means, you know, you can collect this data hidingly, that is chore in Bengali. And if you convert it in geography, then it is a highly vulnerable sediment deposit, and it starts from the debouching point till the confluence of the river in many places. So it is highly vulnerable. If they change in the next flood, you get a monsoon period. So in that case, this area now, people are collecting, but this area there is hardly any stone now, hardly any material now, they are not collecting. So they will use this land after a few years, you will find they are using this land for alternative purpose. And they are the most vulnerable people in the society, and they are the soya, and when flood will come, then people will shout, declare it as a disaster, because thousands of people have been inundated through this flood. Anyway, now you see they are collecting and transporting it, and see this picture in the downside, how much this river is being changed due to this human intervention. So in the beginning I told that chemical changes due to human processes are much more faster than any natural phenomena. Within few days they can change the whole scenery of the earth's surface. So here, this bridge, this is the bridge along this highway. You know this bridge fires, just see this this bridge fire, it is about 5 meters down now. 5 meters have been taken out by the humans. This one. When I started to work in 1993, that time the sediment was up to this part. But within this 25-30 years, people have vanished this sediments from this one, and instead of accretion, river has gone down. Now, if you say it is scientific, it is not at all scientific, because we did not allow the river to maintain the graded profile. That is called science. So, from this, our conclusion is that braid plain formation in the study area is a result of successive flood channel formation. Since all the bars, shoals get submerged in the peak flood, therefore the materials in the braid plain are of recent origin. Most of the bars, riverine islands, shoals, chores, whatever you say, in single term it is called chores. So they are of, most of them are recent origin, and they will vanish also within a course of time. So the dwellers of this chore land, in some cases, if you go to Murshidabad district, I didn't see any presentation of Murshidabad district. If you see, there is an island, their citizenship changes after an extreme event period. So how the people of that chore island will get citizenship? India was elected to give them citizenship. Bangladesh was also elected to give the citizenship. So now, in 1993, so for 1994, there was a devastating, with my supervisor, with all together, who went there, and we have found within one night around 600 meters meander has been eroded, and it has been almost an acute meander. So this is the fury of the nature, and due to this fury of the nature, our role we cannot also deny, and we are the victims, that also we cannot deny. So with these few words,